So, linear regression. That's a topic you've probably heard about on many occasions. But what is it exactly? What problems does it solve in engineering? Are there any easy examples of how it has been used? And finally, what are some of its strengths and weaknesses? Simple linear regression modeling is carried out by taking a sample set of corresponding values, plotting them, and then adjusting the slope and y-intercept of a line such that the squared vertical distances between the sample points and the line are minimized. The resulting model will show one of three cases: positive linear regression, which happens when the resulting slope is positive; negative linear regression, which happens when the resulting slope is negative; and no correlation, which happens when the resulting slope is close to zero. For instance, if we take these fake data points, plot them on a graph, and draw the regression line, the result will be positive linear regression. This implies that as x increases, so does y. However, if we go ahead and plot these points in the same way, we will see a negative regression, which means that in this situation, y decreases as x increases. Okay, that's fantastic, but how exactly is linear regression modeling used in practice? Well, it allows us to determine whether or not there is a relationship between two variables, so we can use it in studies to demonstrate that one variable affects another variable in a predictable way. For instance, the following study was conducted on an LM35 temperature sensor. The error percentage was measured every so often and plotted, with time being the independent variable and percentage error being the dependent variable. The goal was to determine whether or not a linear relationship between time and percentage error existed. To do this, the linear regression modeling techniques we've previously discussed were used, and I've summarized the results in the following graph. The conclusion of the experiment stated, and you can see this from the somewhat gentle slope produced by the linear regression model line, that there really did not appear to be any substantial relationship between the two variables. As with all statistical techniques, it's important to understand the strengths and limitations of linear regression modeling. On the one hand, it's incredibly simple to calculate a linear regression model for a sample of data and gather information about the trends in that data set. However, if the trends are not actually linear, our model will not be very useful, and this turns out to be the largest drawback of using linear regression models. Relationships are often nonlinear, and as such, we often have to turn to more complex regression modeling techniques.